Okay, I'm going to go over how I solved the binary secrets challenge. So to begin with, you can go to retdeck.com. You can Google for retdeck. This is a good decompiler. So just go ahead and select the binary, then click decompile. This is good for some visual stuff here. Everything that's done here can be done in Radar 2. Some of it can be done in GDB, but it's just handy to be able to have it here to flip back and forth. That's what I did, because I'm not familiar enough with Radar 2 yet. So you can look at the complete disassembled code here. Have all the assembly over here, and then the reverse engineered C code over here. This side isn't as helpful. At least for me it wasn't. It was just easier to follow it through here. Anyway, so the way it's structured is all of these, the functions come first, all of the little functions in the program, and then down here away. Okay, here we go. It's at hex D30 at that memory address. That's where main begins. I didn't look through all this here to find that. I found that with GDB. So let's go ahead and open up the terminal here. So the first thing I had to do was change binary secrets x32, that file, to have permission to execute it. Right now it doesn't. I did this actually in Ubuntu. I'm doing it in Kali now. So change it for executable rights. And now I can run it. Otherwise, you can get into it with GDB, but you can't actually run it. And you'll get a permission denied, I think exit code 126. So let's go ahead and open this up with GDB. So the first thing I like to do is set disassembly flavor Intel. It makes it more readable. AT&T assembly is dumb. It's ugly and messy, and it's just way harder to follow. But that's a personal preference. Then we can disassemble main. This will give you the main function. I mean, I just did that initially because main is usually the primary function in a program. That's where most of the stuff happens. Plus, so I did this, then you can hit return to continue. So it's pretty big. I mean, it's not gigantic. I went ahead and copied all of this and pasted it into Notepad, and then printed it out so I could have it in front of me. And I looked through it initially, and I was looking for things like this, like a compare followed by a jump. That's usually like an if statement. So it's comparing values. In this case, it's comparing something to the decimal number 2. So, and then jumping if it is equal to 2, jump if equal, to hex D81. So down here. So if whatever this is doesn't equal 2, it does all of this stuff here, and you can see it prints out something because it calls a print function, and then it calls the exit function. So it prints something and then exits. Without even running the program, and I did run it later, but without running it, I can surmise that probably this is making sure that you have the correct number of arguments or something along those lines, or that the second argument is correct. And If it is, then it continues to run the program from here on out. And if not, then it exits. And that's exactly what happens. You have to have the UID from the challenge to be able to run it. So if you don't, you're not going to be able to, and that's all that's going on there. So then I really just focused from here on in the main function. So what I did was I went through and underlined things that I thought could be valuable later on. Things like calls. So I'd underline the call, I'd put a box around the memory address, and then I'd, maybe underline or put a box or something around any functions or other stuff that I thought was notable. Excuse me. So right here again, this is calling a print function. This is calling, it looks like scanf, so it's probably getting input there. Got another call here, another print function, and then you get a call, and it's related. It looks like a hex address, and it is, but that's calling a function, and this happens to be a user function, one that they coded. And then you look down here, some stuff happens, and then call again, another call, another call. So all of these calls here I highlighted with the addresses over here, the like E31 for this call. And then eventually you get down and there's a put s, so it prints something again. It's just like a put string. And then you're done. Like main function ends. All this stuff in between is pretty much the same. So you're adding and subtracting from the looks like the stack pointer, the ESP, each time, and then you're pushing something onto the stack, probably a variable that it's passing to the function. Well, here we go. We're passing EAX, so that's the variable most likely to the call to the function right there. But it's pretty much the same in between every time. So I ignored all of that stuff. I didn't even pay attention to it. I mean, I would have later if I needed to, but initially I didn't. All right, so at this point, what I did was I set a breakpoint at main, and then I ran it. Let's see if I still have it saved. This is the UID it's used. I'm just going to go ahead and exit out here and open up Ubuntu. Okay, so everything I did before I'm going to do again. Well, that was it. And then set the breakpoint at main, and then we'll run it. Okay. So I need to paste this value again. Get it back. Okay, so it is 5A, 6. I'm going to go ahead and copy this because I will need this again. Okay, what's going on here? Okay. There we go. well, I didn't set the breakpoint or anything. So this is just what the program does. Initially it asks for the right password. We'll try password. And it says got password, so it shows me what it was. And then it gives these numbers 0, 1, 24, 1. It says WOMP and exit. So I'm not really sure what those mean at this point. But it exited, so that's not the password. Let's set a breakpoint at the main. And now let's run it again. Alright, so now we're at main. We're at D41. And we can look at this here. I was following along with my paper, but looks like this is where it starts with the main breakpoint. Main actually starts at D30, but this is all just kind of usual junk that's at the beginning of the main function in every program, getting registers ready and cleaned out and stuff like that. So the next thing we're going to want to do, I looked at this function, this 590, to see if there's maybe something going on there, because it gets called early. And so one thing you can do is look here. I can't really tell what's going on by looking at that, so I'm going to go and look at it in this control flow graph. And again, it just looks like nothing. So that doesn't look real interesting. Get back to here. Something else that you can do, well, that I did, is I guess I did this before I opened it up with GDB actually. So let's get out of here again. I did use Radar 2, but I did it with Kali. Okay, so here we are with Radar 2. Go to the main. So here we are at main. If you hit, so that was using V for view, I guess, and then if in this view, if you hit P, so this allows you to really kind of look through the code and see some stuff. I was following through. I was looking down to see how some of the calls went, and I see that the main's calling all these functions. Here, this starts like the user functions, and if you hit 3, that'll jump to it. Well, it's supposed to. There we go. So something I noticed was, so we've got compares here, and it says compare hex53s. Okay, so it's comparing to a character. S, maybe it's checking to see if it's an S, maybe not, maybe it's doing something else. But then down here, we have another compare, and this is in the next function. You can check with the address 750, hex 750, that's where the next function begins. I see a K character at a compare. Okay. So I look down farther, and now I see a Y, so sky. That seems familiar, and now a dash at the next compare. Now from that point on, it's comparing to, I'm not sure what it's comparing to, but it's adding a character A, then it's adding a character A, again A, and then another A. That seems familiar. 4 letters, like 4 alphabetical characters, and then a number, it looks like. A 0, a 0, a 0, and a 0, and then one more 0. So that was a little odd. I'm not really sure what that was about. And then another 0 down here, and then an X. But what that kind of stuck out to me as similar to, you know, the sky dash 4 letters dash 4 numbers pattern. So that's when I thought, okay, I need to look through each of these functions and see what's going on. So let's get this back into GDB again. Let's set a breakpoint at main, and then run it. So here we are at main. So if we look back at this, I'm looking at my paper that I have in front of me. The first thing I'm interested in really is this call to the first function. It's down here at 6F8, that the call to that function. That should produce an S if you know what I read was correct. Or it should do something with an S. It looks like it compares it to an S. I'm not really for sure yet. So let's go to the next instruction. Forgot what address that was at. So that's at hex DE0 is when it calls that function. So I'm just going to go ahead and skip ahead to that. You can just hit enter to repeat. And then what you hit here is this, I believe it's rep stos up here. And this is basically, it counts down. It's like a counter. I'm not really sure what it's doing in the program, and I don't care because it doesn't matter. So I'm just going to go ahead and enter all the way through it. Now DBB, at this point, we get that printf. So this is what that printf is. It's asking for into the password. So I wrote that down on the paper and noted that. So I feel like this could, you know, be something. So I just tried this to begin with because it was pretty similar to what was in there. Maybe that's what the code is. Then again, we want to just go ahead and keep moving along until we got to DE0. Well, there's that next print function. After the, well, sorry, before that, so it printed and then it asked for the scanf. So scanf and then this is the print, and I guess I noted both of those. But here we go, we're almost to where we want to be, DE0. So if you hit next I, it's going to skip over that function, and we want to go in and see what it's doing. So we're going to step into step I. What I did here, I just looked at the registers to see what's going on. I don't see anything real interesting at this point. So if you look back here, we can go to 6F8. So here's this function that we're in. And what I noticed here, so there's a call here to something, and there's a compare. And it compares it to hex 53. And then again, there's a compare to hex 53. And if you look at the ASCII table, hex 53 is S. So that's the function it is. It's comparing it to S, comparing something, some value to S at that point. So let's see what happens here. Let's keep stepping through. If you look here, the compare is at 70F. So that's what we're interested in. Let's check the registers here, what's going on. We'll step again after the compare. So you'll notice here that So 83 is an EDX, and decimal 83 is an S. So that is what I was comparing. Absolutely right there. So I did this a few times to see if anything else changed. And we're back in the main again, so I don't need to keep looking at the registers. So I did that for the next few functions, and it went sk, y, and then the hyphen. But then something weird happened, and it didn't compare the hyphen later in any of the in one of the functions. But what I noticed before I even got that far, looking at the control graph here. So this is pretty easy to follow too. This is another way I kind of looked at it. If A1 doesn't equal 83, which is S, then do something. Otherwise, do that. So it looks like it's checking to see if it's an S there. And on this one, 75. Well, spoiler alert, 75 is K. Then the next one, 89 is Y. And here it says it's comparing it to 45, and 45 is a hyphen. You'll notice here that it's assigning A1 plus 3, whereas before is A1, then A1 plus 1, then A1 plus 2. But then it's also saying if V3 doesn't equal A1 plus 8. Well, if you skip ahead 8 places, there should be a hyphen in both of those spots. So it's saying that there should it's assigning the value here and also to that one. So it's saying that if it's not in both of those places, then exit. So it's doing a double check here. And then the next one here, you go down and see what letter it's comparing it to, and you can't tell because it's doing this crazy calculation right there for the comparison. And that's really why you have to use GDB or something to step through and look at what's going on, some sort of debugger or decompiler. So I'm just going to skip ahead here to the call to X hex 852. That's at hex E1F. I want to step I again so that we want to go over it. So now that we're in it, let's look back again. Whoop, not there. So here's function 852, and there is a compare down here at hex 8AB. So we'll skip ahead to 8AB. And I don't know if there's a command to do that, but I don't know it if there is. So you look at the registers there. You have 65, which, if you look in the ASCII table, 65 is A. Well, that's what we entered. So it looks like whatever the user entered is going to be in the ESI field at this point, and 67 may be what it's going to compare to. And yes, it is. So then we keep going through the rest of the function, and since it didn't compare correctly, A wasn't whatever the letter 67 is, which, I mean, if it's only 2 more, that's going to be a C. You can look at the ASCII table to verify that, but it is. It's a C. Then it exits, and it exits with a 4. So if you do this again, and then enter the password, so let's do this. Run, paste the UID. I'm going to go ahead and skip through until we get to the thing here. Okay, so I'm going to go ahead and enter this with a C, and I'm just going to keep doing the same old thing there. Skip ahead, and at the next function, it is at hex E31. So we're just going to go next instructions until we get to E31. So again, it shows the code that you entered in as a user. And then step into it. And then now we're into it. Let's go see where it's going to be at. That's not what I wanted though. Okay, 8CE. So there's some calls and stuff, garbage, and then here's a compare at hex 924. So we'll skip ahead until we get to 924. Let's look at the register here. So it looks like there's an 86 in the EAX. And it's still there after the compare. So that 65 is our A, 86 is probably the next letter. And look here, decimal 86 is a V. So now we've got Sky-CV. Let's go ahead and head to the next instruction, see what happens here. Now we get a 5 and an exit. So last time it was a 4, this time it's a 5. This number apparently is telling us how many letters were correct in our entry, which would make sense. SKY-C is 5, and then the V was incorrect, but we saw that it should have been V. So you just run this process over and over again until you finally get through the last function, and the last 4 functions give you numbers instead of letters, and that's how you get the password for this. And then you can just verify that it's the correct password by testing it out here. So I'm just going to go to the next instruction here, skip ahead. So here we go, enter the password. And just can keep going ahead like this to skip through everything. I think actually I can just hit next, and it goes until the end of the program, and there we go. Woot, you got it. Got a moose. That's it. That's how you solve it, or how I solved it at least. I'm sure there's other ways. Hope that was helpful.